then have a quick look at hydrogen, then I'll wrap up. Hydrogen is often talked about, and so I think it's interesting to have a quick look at it. First item, of course, it's often ignored by many in the media. It's not a source of electricity, or it's not a source of energy. It's just a carrier. You have to produce the hydrogen to begin with, and then you can reuse it in a fuel cell or in many other ways of using hydrogen. But hydrogen, though it's the largest amount in the universe is hydrogen, it doesn't sit around as basic hydrogen for very long. It tends to react with something. So to use it, we have to unreact it by taking water and breaking it down or some other method. Electrolysis is one of the main ways. Again, like all processes, one never gets 100% efficiency because you end up having to do extra work to do it. So you'll have about 85% efficiency. And if you're doing from a typical hydroelectric plant, it's not hydro, I should say, but a plant like a nuclear reactor or a coal-fired plant or something like that. Coal fire doesn't make much sense, but if you're using it, you're only about a 35 to 45% efficiency from the thermal. So that, and I guess a 10 to 15% from solar. So you lose a lot in actually trying to get it by the time you produce the electricity and then the efficiency of breaking the water into it. So it's not a great way of getting hydrogen going this route, but it's the most useful one. Longer term, there is the possibility from fusion, and it's one of the methods talked about. But it has to, fusion's been a 40-year horizon for most of my 40-year career. So unfortunately, I think fusion will still may not continue to be a 40-year horizon, but I would still place it in a 30-year horizon. If you ought to see, you should go what sort of horizon fusion has in your young careers. And so there is one of those, Ron W., who often gives talks at these like science academies during the summers, a scenario of using a hydrogen and from nuclear reactors to produce zero greenhouse gases. And he puts these sort of numbers into it. You can ignore most of those, but it's basically, this was based on the old ACR 700 reactor that we were working on a few years back that produced 700 megawatts of electricity. And it ends up, he's gone through the math. I haven't actually checked them, but Romney was pretty careful what he does. So it's the order of 650,000 fuel cell vehicles a year from one reactor. However, again, if you take that and you put it into real numbers, you take a number like 150 million, and again, that's compares to the advanced gasoline. I'm guessing it'd be about right. There's 300 million people in the States, more or less, so at least there's half as many passenger vehicles out there. And you hold 1,000 megawatts or so for a nuclear power plant. You end up finding out that you need something like 200 new power plants to provide the hydrogen for passenger vehicles. So it's well doable. It's a massive undertaking. And as I noted down here, there's not a lot of public discussion on those issues, either U.S. or Canada. And one other comment on hydrogen, just for as well worth thinking about. This one looks at energy content issue from a point of view of energy per unit volume rather than the energy per kilogram. Because hydrogen is so light, it's got very, very good energy per kilogram. But to use it in anything portable like cars, you've got to actually store it as content. And so if you look at different types of fuels here, what sort of pressures, and the energy contents in terms of megajoules per liter of volume. And gasoline, which is what we've all been living with in our internal combustion engines for years, is about 33 megajoules per liter. For propane, which is used in a number of applications, is 25. You get yourself down to natural gas, which is the methane, is about 8. Hydrogen, even at nearly 3,000 pounds per square inch, is only 2.5 or 8% of what the gas in a tank at ambient pressure. Even if you go up to 11 or 12,000 pounds here, it's only a third of what gas is. These are sort of very, very high numbers to be thinking of in terms of a tank of hydrogen in your car. So there's a higher efficiency potential from using hydrogen in fuel cells, but it's very hard to realize the sort of massive storage of hydrogen that gets you 400 or 500 kilometers of a distance, or 600 or 700 that most of your vehicles have now. So these are going to continue to be the sort of problems that plague widespread introduction of hydrogen into general use. Transportation requires energy content stored in a practical manner. 10,000 psi tank, that's 800 atmospheres of pressure roughly. So that's a lot of pressure. It can certainly be done, but the tanks get fairly heavy, and the higher that pressure, the car accident that actually has one blow up is probably going to be a fairly serious one. And I think I'll skip through that another thing. So I'm just going to get to this and sort of go over main thrusts of this presentation. This is a summary. And energy, climate change, they are major issues, and they'll be, I think, more and more of a major issue as we go forward. And certainly throughout the year, these young groups here tonight, as their careers evolve, I'm sure they're going to see a lot more about this than we've seen in the last 10 years. As you're going forward, look at the various things that you read, and look at them carefully. Look at the serious view about the values and strengths of the supporting evidence. What are they actually saying, and what are they backing it with? And then use your skills, your own skills, which are rapidly evolving right now. I mean, your people are at an age where you're gaining new skills very, very quickly. Use them, and as I say, have a single sheet of paper. Often a lot of this stuff can be done very simply. And the big picture overview, which you can do from this very straightforward approach, is often more valuable than a lot of supporting details that are often cherry-picked, so to speak, to support there are often details that are presented to support something that are carefully picked, and other ones that are not so supporting that are not presented at the same time. So one should take a careful look at what's being said. And so in conclusion, I was going to say, just use your ability to think. Use critical thinking. And I'll wrap it up with that.